Hi everyone, Mrs. Bianchi. We're going to do a little bit more with modeling two-step equations, and I really think modeling will really help what I call that deep conceptual understanding. So remember when we have something that's balanced, we're suggesting that it's equal. So if we look at what's on the left, we're going to call this n, and we have three of those. So we would write that as 3n, and yellow represents positive, and these would each be equal to 1. So we have two of those, right? 3n plus 2. And what we have on this side, if we count, we have 1, 2, 3, 4, 5, 6, 7, 8 of those. So we're going to write the 8 over here. All right. Now we're going to explore why is it that we apply the inverse operation. We learned about the equality property. Whatever you do to one side of the equation, as long as you do it to the other side, you're going to the equation will remain balanced or equal. So we're going to take advantage of that by taking off these two. So if we take these two things off, that on paper that would look like this, we're removing two of those, which means we'd have to do the same thing over here. We'd have to take two off of this side. So let's see what that would look like. Take these two off and put them in my bank. Take these two off and put them in my bank. All right, so usually on paper, we would draw a line. We would show that this equals nothing, right? Because there's nothing there. So we would just, maybe put a line through it. We would bring down the 3n, bring down the equal sign, and then you would ask yourself, what are we left with here? We're left with 6. Isn't 8 minus 2, doesn't that equal 6? All right, but we're not finished yet because this means 3 times some number would equal 6. On paper, we would say to ourselves, well, what's the opposite of multiply a variable by 3? And the answer to that would be divide by 3. We'd show that with a fraction bar. And whatever we do to the left side to keep it balanced, we have to do it to the right side. So we would simplify this. It would give you 1. 1 times n is n. And 6 divided by 3, we can do that mentally. That would be 2. But let's look at the model of how we would get 2. Let's go back up to the model. And we want to look at our equivalent groups. Now, I've arranged this to make this a little more obvious, but if I had put the yellow markers in the pan in a different way, this would have been a little bit harder to model. But we want to show our groups. So here's one group. Here's the second group. Here's the third group. So if I pick one of the ends, let's say we're going to pick this one, because they're all the same, right? If we pick one of the ends and we count how many are in each group, isn't it 2? So doesn't n equal 2? Like we just look at, if we ignore the rest of it and just focus on this first circle or oval that I have here, that shows that n is equal to 2. And that's what we got. Now, if we were going to show a check, we would go back to the original equation and rewrite it. So remember, it was 3n plus 2 equals 8. We would take our solution that we got, which was 2, and we would substitute that in where n was. So this 2, we would substitute it in for n, and then we would continue writing the rest of it. We would go ahead and do the math. 3 times 2 would be 6, and then bring down the rest. Plus 2 equals 8. And of course, 6 plus 2 equals 8. So since this side matches this side, we can say, oh, good, it's correct. It checks. All right, so how about we look at a different example? So let me erase all of this, erase all of this. We're going to change it up a little bit. All right, how about this time? Let's throw on another n. So what does that mean we have so far? So if we start this out, we have 4n. And how about this time we add to that? We'll still keep the numbers positive. So how about we throw on here, I don't know, how about we'll do about 8. So far I have 4. Let's put another stack here to make that 8. All right, so forgive me for being a little slow. All right, so 4n plus 8 equals, and then on the other side, maybe I should draw a line or something to separate that a little bit better. So let's bring on a few more of these. Let me bring on a few more. Let's clone that. Clone this. So what do we have now? 12. And let's put on a few more. All right, actually there might be something interesting about doing this. All right, so what do we have here? We have 16, right? On this, in the right pan, if we count, it's 4 going this way, so there's 16 there. All right, 4n plus 8 equals 16. All right, so if we're going to solve this, what would we do? What could we take off of both pans? Because remember, whatever you do to the left pan, you have to do it to the right pan. All right, well, some of you might be accustomed to the idea on paper. What would it look like? You would say, what's the opposite of add 8? It would be subtract 8, and you would subtract 8 from both sides. So let's look at the model for that. That means we're taking this off, which means we can take this off. If we take it off from both sides, the equation will remain balanced. All right, so I'm going to just pull those into the bank, but I just wanted to make sure you saw that. All right, we'll pull those off so you can see what we're dealing with here, and these all need to come off too, because whatever you do to the left pan, you got to do it to the right pan, otherwise it does not stay balanced. All right, so now that they're off, we can delete these things, because I just wanted to show you that we were taking those off, but we can delete that now. All right, so what are we dealing with here? We still have the 4n over here in this pan, so I'm going to bring that down. Now remember, all this canceled out. Some people like to put a line through it, but let's rewrite the 4n. Let's rewrite the equal sign, and let's do the math. What is 16 minus 8? How many of these things do we have? And if you count them up, we have 8 of them. 16 minus 8 is 8. All right, so we're not done yet, because this means 4 times some number equals 8. Now, if we apply the inverse operation, the opposite of multiply a variable by 4 is to divide it by 4. What would happen over here? This would simplify and equal 1. 1 times n is n. And what's 8 divided by 4? Well, we know it's 2. We can do that in our head. Let's look at the model. Let's look at the model, because we're trying to figure out how much in each group. So if we circle the groups again, so here's one of the n's, and we have 2 in that group. We have 2 in this group. We have 2 in this group. And this n also has 2 in each group. And we're talking about one of the n's, how much in each group. And you can see that we can pick any one of the blue ovals, and count how many are in there. And that's your answer, which we already know to be 2. Now again, how would we show a check for this? We would go back and write the original equation, which we call is 4n plus 8 equals 16. You would substitute in for n, you would put in what we got for n, which is right here. We got 2. And then we would continue with the plus 8 equals 16. Then we would go ahead and multiply this. That would give us 8. And if we do 8 plus 8 to see if that equals 16, the 16 equals 16. So it checks. So here, this is called inverse operation here. Over here, we would call this substitution. So this is solve, and this is the check. All right, so I think we have time to maybe do one more. Let me erase all this. And let me erase our work from here. And it might be time to start talking about negatives. So actually, let's do a stack of these on there. Yeah, I think that'll be good. I think that's going to be perfect, actually. All right, so what do we have here? We have 4n, and we would interpret this as not positive, but a negative 4. And that equals, and yellow, remember, we're using positive, so we have 4 on this side, 4 on that side, so that's 8. So we have 4n minus 4 equals 8. All right, now we want to try to get the variable isolated on either the left pan or the right pan. So right now it's on the left pan, so we have to ask ourselves, what do we have to do to get rid of this? And the answer is we have to apply the opposite. So the opposite of that would be to add 4. And whatever we do to the left, we have to do to the right. So what would that look like if we model it? If we model it, we would be bringing on 4 of these. So let's see what that looks like. And that means that we also have to bring on 4 of these into this pan. So that's 1, 2, 3, 4. All right, so now what are we dealing with here? Well, let's talk about the zero pairs again. For every zero pair, this is a zero pair, they cancel out. Here's another zero pair, they cancel out. Here's another zero pair, they cancel out. Here's another zero pair, they cancel out. So this ends up being nothing. Everything in this blue circle disappears because they cancel out. All right, let's bring down the 4n. Let's erase what I had from before. Let's bring down the 4n. And now let's ask ourselves, what do we have over here? If we count, we're just basically adding 8 plus 4. What is 8 plus 4? Well, it would be 12. All right, so now what's the next step? So knowing that this is gone, what's the next step? It's to ask yourself, what's the opposite of multiply a variable by 4? And it would be to divide it by 4. This would cancel out, or it would equal 1 is probably a better way to say that. 1 times n is n. And what is 12 divided by 4? Well, it would be 3. Now let's model it. If we go back up, now remember the stuff that's here is gone. In fact, it's probably a good idea that I just move it out of there so we don't get confused because it zapped out, it disappeared, it's gone. So let's get rid of it so we don't get confused. All right, so now let's show our different groups. So this is a group right here. And really, all we need to know, as long as everything's broken up into equal groups, just circling one of the groups, you can see that the answer is 3. But see, each group of n has 3 in it, which just shows you again why n is equal to 3. And since these are yellow, right, it's positive, it's a positive 3. Now, of course, we could go through the process of showing a check. I think you kind of get it with the check. You're just going to substitute the 3 in the place of n and make sure that the two sides are balanced and equal. But hopefully seeing the model has helped you understand a little bit more about two-step equations.